classes, but I don't think I did one in here yesterday. Did I? I didn't do an example from Delta Math, did I? Okay. I will do one today in a minute, but first we'll get through this lesson. Now, we're going to talk about probability today. First, I have a warm-up on vectors, but I need you to realize that for some of you, probability is going to be very intuitive and it's going to make perfect sense. And some of you, it's not, and we're going to have to think and process a little slower. So you can kind of work at your own pace. That homework tonight is Delta Math. All right. So first of all, on 15B, our warm-up problem on vectors, there is a question just like this on the quiz. It is not a difficult question, and I think I worded it a little better than this, but it says there's two forces, an 85-pound one and a 120-pound one. One is acting at 35 and one at 45. I think I made it a little clearer that it was 85 pounds at 35 degrees and 120 pounds at 140 degrees. I didn't do this whole respectively business on the quiz, okay? But you could draw these, but there's really not a need because we have the information to do the components already, and we're supposed to add them. The resultant means they're being added. So I'm going to do 85 cosine of 35, comma, 85 sine of 35 for the components of the first one. And for the second one, which number goes out front, guys? The 120, because the 140 is degrees, which means we need to be in degree mode. I put that in the directions on the quiz, so just make sure you read directions and you should be good. All right, then you're going to type what? You could type these in and get decimals. I don't usually bother. I just add the x's, but you have to type it all in. Someone will add 85 and 120 and put it down here or something. That doesn't work, okay? So we're going to put in 85 cosine of 35, close your parenthesis, plus, someone help me, 140, or was that the angle? 120 cosine 140, thank you. Someday I'll figure out how to do like a half screen. And then we do the same thing with sine. Am I typing it right? Are we getting the same things, guys? Did somebody else get those numbers? Okay. Negative 22.3 and 125.9 we'll go with. Negative 22.3 and 125.9. Did I remember them right or not? Okay. That is the added resultant vector, okay? But it is not the resultant magnitude or direction. How do we have to find magnitude and direction? Magnitude means do what? So the square root of 22.3 squared plus 125.9 squared. $127.9 maybe? And that was pounds, because that is the, what am I trying to say, magnitude, yeah, magnitude and direction, so that's the magnitude. And then we need the direction, and how do we do direction, guys? Inverse tangent. But before we do that, what quadrant, if we were going left and up, what quadrant are we in? Okay, this is a quadrant 2 number, right? And in quadrant 2, the calculator never gives us the right answers. So we're going to go inverse tangent. It's always y over x Inverse tangent, 125.9 divided by negative 22.3. I got negative 80 degrees, anybody? Okay, if I were to think about where negative 80 is, it's clearly not in quadrant 4. So what do I need to do? Add 180. And that puts me at 100 degrees. Is that in quadrant 2 where we were supposed to be? Did I just say a minute ago this was not in quadrant 4? Yeah. Okay. It was in quadrant 4, not in quadrant 2 where it was supposed to be. I don't know, my mouth is not agreeing with my brain today. All right, this is how you had to do the delta math as well, but at the end on the delta math, you would have had to write 127.9 in one box, and then it would have said cosine of blank, sine of blank. So this is putting the final answer in as a vector, and they leave the magnitude out front, so you would have put 100 degrees and 100 degrees, okay? I don't know why they put that final answer in that way, but that is the extra step on delta math, but I'll do an example later. All right, let's talk about prob and stats for a little bit. The learning targets today are defined probability and odds of an event. Actually, I'm not sure. Odds wasn't in delta math, so I think we'll save this for when we get back from spring break. And we're going to do independent events, dependent events, sample space, and I think that's it today. The rest of this is tomorrow. All right, so this is the first page. Does this look like the top of page 1 in the new packet? Did everybody pick the new packet up? Was there enough? I didn't run out, did I? Who's gone today? Ben, yes? Okay. Yeah. Does everybody have it then? Okay. So at the top, it says basic probability, and it says first we're going to talk about experimental probability. So the definition is here, number of favorable outcomes over a number of possible outcomes. I like to shorten it, but I would write the longer one if it's new to you. I kind of think of it as winners as over all the possibilities. Okay, whatever we want to happen over all the possibilities. So it's number of favorable outcomes over number of total possible outcomes. So let's do a couple super quick examples. If we have a coin and we're going to toss it, what is the probability of tails? That's how we write that. This means probability of tails. So theoretically, when you flip a coin, the probability of tails, well, there's one tail out of 2 ways the coin can land. Is we making sense? Now, the other one that's very common is to talk about a die. I believe the SAT refers to it as a 6-sided number cube, but it's numbered 1 through 6, okay? So what is the probability that we roll a 2? 1 out of 6. Make sense? Questions? I hope you've all done some of this before. Experimental probability is the number of times the event occurred, so what you got, again, winners, out of the number of trials. In other words, it's still out of total, but it's not in theory anymore. It's out of what actually happened, okay? So experimental is what happened. For example, I'll put an example in here that you can write down, but let's just talk about this one that's on here for a second. It says they spun a spinner that had an X, Y, and Z on it. I don't know if the spaces were the same size. I would guess not. But they spun it a total of, does that add up to 20, guys? 13, 16, 20. I think so. They spun it a total of 20 times. So if we had said the probability of X landing on X, it would have been 4 out of 20, which we could have reduced to 1/5, okay? You don't need to write that down. Let me give you a real easy example if you want to write one down. Let's say we flipped a coin and we had a little tally chart. Does that make sense? We had tails and heads, and we had 3 tails and 5 heads. So what is the probability of tails here? How many times did we get tails? Out of how many trials did we do? 8. Is everybody okay? Anybody lost? 3 tails. This little means 5 heads, so a total of 8 trials. So even though in theory, the probability of getting tails is 1 out of every 2 or half, we did an experiment and got tails 3 out of 8 times, okay? That's the difference between those. You will not have to do, oh, well, I won't say that. The probabilities in Delta Math are largely theoretical, but there is a little talk about, like, Susie hit 22 out of 24 free throws the last time she was at the line. And it will say, choose the word that best describes the chance she makes her next free throw. And it's like, likely, not likely, almost impossible, or can't happen. So you would say likely because 22 out of 24 is pretty good probability she's going to make her next one. It just does some describing like that. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 people here today. So out of 17 in our class, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, maybe we'll say are girls. And I know this is not gender appropriate anymore. I apologize, but they do this all the time. So if we have 12 girls out of 17 students, what is the probability that we pick a girl in our class? 12 out of 17. Okay, any questions there? I apologize for the not appropriate question. A deck of cards are in our examples. I don't know that it's used in Delta Math. I know some of you, how many of you are like not familiar with a deck of cards? Anybody gonna fess up? Yeah. Most of you are, seems like you know something anyway. There are 4 suits, okay? So that's what you need to know. There's 4 different kinds. It's ace through 10 and jack, queen, king. There's a total of 52 cards, so there's 13 of each of these for a total of 52. Does that seem like enough information? Okay. So out of a deck of cards, or 52 cards, how many would be red? So there'd be 13 hearts and 13 diamonds that would be red. Does that make sense? So 26 out of 32, or 52, sorry, or half the cards. I think you could have guessed half, yes? All right, what about hearts? Yes, 1/4, or 13 out of 52, but you can just put 1/4, that's fine. All right, this is where you have to know a little bit more. What about red 7s? There would be 2, right? 1 heart and 1 diamond. Everybody okay? So 2 out of 52 would reduce to 126. There we go. Were there any hearts that were black other than Hofbauer's? No. Hofbauer doesn't have a black heart. All right. So it is possible to have a probability anywhere between 0 and 1, 100% of the time, okay? A sample space, when you roll a dice, they want us to show the sample space. A sample space means list everything that could happen. So what are the things that could happen? You could roll a 1, a 2, a 3, a 4, a 5, a 6. Sample spaces can be very complicated depending what's going on. This is an easy one. So what is the probability you roll a 4? 1 out of 6. What's the probability you roll an even number? So the winners are 2, 4, and 6. So that would mean 3 out of 6 or 1/2. I'm sure for most of you this is very basic, but I just feel like some of you maybe haven't done this in a very long time, if ever. The probability you roll a number greater than 1. Okay, now we got to have a little math sense. That's going to mean 2, 3, 4, 5, 6 are all winners. So 5 out of 6. Everybody okay? What's the probability we roll a 7 on a single die? 0. Everybody good? All right. These are the worst name choices ever. Let me start writing and you'll understand why. We're going to list, it says Bill, John, Sue, and Ann were all up for a promotion. Their boss is going to choose a team of 2 people to lead their department. Everyone is equally likely to get the position. Show the possible combinations for this leadership team. So we have Bill and John. We have Bill and Sue. We have Bill and Ann. Is anyone amused by these yet? And we also have John could be with Sue or John could be with Ann. We have Sue could be with Ann. I think that's all the possible ways, right? Is Sue up there 3 times? Yes. Is Ann up there 3 times? John, okay. No one giggled. The first 3, really? All right. Is everybody clear that we don't need to list John and Bill? Because that's the same team as Bill and John, right? Okay. So the order they're picked in didn't matter here. So there are how many ways we could pick this team? 6 different ways, okay? It did say show the possible combinations. Now, what is the probability that Bill and Sue get the promotion? So BS was 1 out of the 6. The team is made up of 2 men. Okay, we're going to be gender assumption here, but we're going to assume Bill and John are the 2 men. So the only team that wins is the one that has the 2 of them, right? It's 1/6 again. BJ is our only winner. Okay. Ann is one of the people getting promoted. So how many of the teams included Ann? 3 out of 6 or 1/2 was our probability. Any questions on that one? Other than the very amusing name choices and the fact that it was gender specific again. Another gender one. I typed these out because it hurt my head to write them. A couple is planning on having 4 children. Write out the possible gender outcomes, and birth order would constitute a different outcome. It could be boy, 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 girl, boy, boy, girl, boy. These all, I listed the ones here that had 1 girl. So the girl could have been second, the girl could have been first, third, or last. Then I did down this last row, all girls, 1 boy last, 1 boy second, 1 boy, or this one second, third, first, okay? Then this one is all the possibilities of 2 boys and 2 girls, okay? Now, another way you can do this is this kind. Has anybody ever done one of these guys? A tree diagram? So they did it in color coding. So the red is the boy. So this would be boy, 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 girl. Because it went boy, then boy, then boy, then boy. Oops, that's the first one. The second one here would be boy, 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 girl. Anyway, it's a hot mess. I don't like this method a lot, but that was listing all the possibilities. I would not give you one on a quiz with that many possibilities, okay? Unless it was simply to ask, what's the chance of all girls? Well, what you really have to know here is that there's 2 choices for each of 4 children being born. So that is a total of 16 possibilities. Did that work for what I wrote? 1, 2, 3, 4, 5, 10, 11, 12, 13, 14, 15, 16. I had 16 possibilities, right? So how many of them had all girls? Only 1. What's the probability of all boys? 1. Now, this seems really complicated. At least one boy. Seems like you're going to have to start counting a lot of choices, right? Does anybody know another way we could word that would make it much easier? At least one boy is every choice except what? All girls. Okay? So it's going to be 15 out of 16. At least one boy. We could circle them all. Everybody that has a boy, this. Okay, this is the only one that didn't have a boy. So at least one boy meant not all girls. So it was 15 out of 16, okay? So this was a really ridiculous question to have you write out all those choices because it didn't say how many of them had a boy born second or something that would have been useful. This was, you could have done without ever listing them. All right, we're going to talk a little more specifically about probability rules. The probability of an event is denoted by this, P of whatever the event is, okay? P of tails, whatever you want. The probability of an event is always the number between 0 and 1. The closer to 1 it is, the more the event is likely to happen. Now, I need to talk about Delta Math for just a second. In Delta Math, they will ask you one of 3 ways to determine your answer, and you have to know them, okay? It will say, give a percent, and you don't type the percent symbol, okay? So if it was of getting tails, you would put in 50 for that percent. Does that make sense? They will say give an exact probability, and that wants a fraction. So you would put in 1 out of 2, okay? Or they will say give a decimal. What would the decimal for 50% be? 0.5. Is everybody okay? You just have to be able to change decimal to percent and percent to decimal from a fraction. I think you'll be all right. All right. The sum of the probabilities of outcomes in a sample space is always 1. So if you add up the chance of getting a 1, a 2, a 3, a 4, a 5, and a 6, it should always total 100% because those are all the choices on a die. Make sense? This is what we did on the last question. The probability of an event not occurring is 1 minus the probability that it occurs. That is known as the complement. We wanted the probability of at least one boy. So we said, well, what if we did the probability of no boys, and then we subtracted kind of in our head, okay? So it's known as a complement. Here's an example. If the chance of an event occurring is 3 out of 5, what's the chance that it will not occur? The probability it will not occur. If 3 are winners, 2 are losers, right? It's 1 minus that. Does that seem to make sense? Another way, I don't know if there's an example on here, so before I go, no, there's not, but it's one of those, like, it's 20% chance of rain, so there's 80% chance it won't rain, right? That's all we're talking about there. All right, independent events are events that do not affect each other. If I'm going to flip a coin and roll a die, and I want to know the chance that I get heads with a 6, it doesn't matter that I got heads, it's not going to change the probability of getting tails, right? Or of 6, whatever I'm trying to say. It's different than if you have a bag of marbles and you pull one out and you leave it out, then it changed the probability for the next one. That's called a dependent event. All right. If you roll a dice and flip a coin, what's the probability you roll a 5? It says, by the way, here, we're going to multiply. So when you roll a 5, that was a 1 out of 6 chance. Everybody good? Flip a tail would be 1 out of 2. So the probability that those 2 things happen is 1 out of 12. We could list them. We could write 1, 2, 3, 4, 5, 6 with a heads, 1, 2, 3, 4, 5, 6 with a tails. And that would be a total of 12 ways it could happen, and only one of them would have had a 5 and a tail. Make sense? Okay, if you roll a pair of dice, what is the probability that you'll get a pair of 3s? Well, the one dice has a probability of 1 out of 6. The other dice also has a probability of 1 out of 6. So there's a 1 out of 36 chance that you would get 2 3s. One dice does not affect how the other dice lands. Does that make sense? If you listed all the possibilities, there are 36 ways they could roll. You could have a 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, and a 1 and a 6. Then a 2 and a 1, a 2 and a 3, blah, 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 blah. Okay. This is using the idea of a complement. It says the chance you pass a test is 40%. Test A. Test A. The chance you pass is 40%. What is the chance that you fail test A? Can we go right down below that? 60%, because you either pass or fail, okay? That's our assumption here. It says here, note the tests are independent of each other. So one's a math test and one's a history, totally separate, okay? The chance that you pass your test B, we'll call this your biology test, how's that? So we have an accounting test and a biology test, A and B. So the chance you test your pass your biology test is 20%. The chance you fail your biology test would then be 80%. Everybody with us? Okay. What do we do? And I made a little chart here that might have helped some of you. I know Delta Math shows a little chart, but let's see. A pass was 40 and 60, and B was 20 and 80. Okay. What is the chance that you both fail A and fail B? Well, do you remember what we just did on the last one? They're independent of each other, so you multiply the probabilities, okay? Now, these are percents, so what do we want to do to multiply them? Yeah, change them to decimals, good call. So the fail A would be 0.60, and fail B, we're looking right up here if you have this, would be 0.80, which is 0.48, or Delta Math might ask you to give it as a percent to the nearest whole number, so then it would be 48. You don't put the percent in, though, in Delta Math, okay? No symbols in that box. Pass A, fail B. Can you guys do all these? Pass A and fail B. Fail A, pass B. So what did you get for fail A, pass B? Anybody? For this one over here, is that the one you're? Okay. What about this one? Yep. 0.12 or 12%. And pass, anybody? Only 8%. Okay. Go ahead.
You have to write like point the number, because I just wrote the percentage.
No, I don't care. Yep. On the quiz, I will accept any of those three, the fraction, the decimal, or the percent. We usually do them in fractions. This was a percent, so a percent is probably how I would have answered as well. Delta Math specifies what they want. Note these are all the possible outcomes. Everybody good? There's only two. You can fail, pass, fail, pass, pass. That's it. So what should all those probabilities add up to then? 100%. Or 1 if you added them up as decimals. Okay? 48 and 12 is 60, 32 and 8 is 40, 60 and 40 is 100%, right? So it works? Okay. Now, dependent events, okay, are multiple events that affect each other in some way. So you can multiply the probability of A times the probability of B given that A occurred, or the probability of B times the probability of A given that B occurred. This is all fancy talk. It just, my way of thinking about this is without replacement, meaning you didn't put the first one back, so there's less of something. So let's talk about a deck of cards again. How many cards are we talking about? 52 cards, okay? On the first draw, it says, what is the probability that you pull 2 aces in a row without replacement? I would specify you're not putting the card back, okay? So the first time, there's how many aces in the deck? 4 aces to pick from. So 4 out of 52 is the first card. But without replacement, once you didn't put it back, so there's now only 51 cards on the second draw. Does that make sense, guys? So how many aces are there left, though? It's always assuming you won the first time. Okay, so how many aces are left to pick? 3 out of 51 cards. Is everybody good? Okay. I think it actually reduces to 1 out of something, but it's a big number. Maybe I'm wrong. So 4 out of 52 times 3 out of 51, which actually reduces because 51 is not prime, even though it seems like it. Math, enter, enter. Okay. I just wanted to show one on the calculator. All right. You have 30 students in your class. Again, with the gender thing, 17 are boys, 13 are girls. We need to select a president and a vice president. Are these dependent or independent events? If we are going to randomly pick out of our class, okay, there are 30 students to pick from the first time. How many of them are boy, or we'll do female first? Oh, it says female, female. I can read. How many of them are female for the first try? 13 out of 30. If we chose a female president, how many are there now to choose as a vice president? 12 out of 29. Okay. Do I need to write an explanation of that, or is everybody okay? I don't think my answer key was right for this because I think I misread the question. 13 out of 30 times 12 out of 29 is nothing nice, is it? Out of 145. It was about 18%. It was 0.179. So if Delta Math said as a whole number percent, it would ask you to round it to 18%. The fraction is what I would have looked for, but in Delta Math it specifies. All right, this might be our last section today, I don't remember. Sometimes, this is really weird, I never do this, okay? I never use this. It says the union of probabilities. If you are asking an or question, the probability of A or B, you can do the probability of A plus the probability of B minus the probability that A and B happens. They're called mutually exclusive events. In other words, one doesn't affect the other. I do not ever do it this way. I just use logic, but if someone needs me to go back and explain it differently, let me know. It says, from a deck of cards, what is the probability of pulling a red card or a 2? Or means either one is a winner. So I just think about how many total winners are there. How many total red cards did we decide? 26. Now, it says or a 2. Well, there's 4 2s, but have we counted some of them already? Yeah, 2 of them are red, so there's only 2 more that we have to add. That's where they say you could add all the red cards, all the 2s, and then subtract the red 2s. That just seems confusing to me. But there's a total of 28 winners out of 52, which reduces by 4 to 7/13 maybe. Anybody checking me? Okay, I'm just gonna do fractions because that's what I do on the quiz, but rolling a dice, what is the probability of rolling a 6 or a 3? Again, just total number of winners. If you are rolling the dice one time, how many winners are 6s or 3s? 2 out of how many ways it can land? 6, so it's a 1 out of 3. Does that make sense, guys? Rolling a dice, what's the probability of rolling a 6 or an even number? Now, this is one with overlap, right? But how many are either a 6 or an even number? Well, 2's a winner, 4's a winner, 6 is a winner. We already got 6, so it's a total of 3 out of 6 or 1/2. Everybody's good? This is worksheet 2. But I think this might be on day 1. I'm going to talk for 2 more minutes here. In a math class, there are 14 seniors and 8 juniors. Okay. This is one that I think might be helpful to have a table. So we have juniors and seniors, and again with the flippin' gender stuff, but we're going to go male and female. All right, 5 of the seniors are male, so I have 5 seniors that are male. 4 of the juniors are female, so I have 4 juniors that are female. This assumes gender is either female or male, I apologize, but if there are 14 seniors total, how many do we know are girls? 9 are female. Does that make sense, guys? 14 minus 5 leaves 9 for that box. 8 juniors total. So if there are 4 female, there are 4 male. In Delta Math, they gave you a table usually, okay? What's the what's the probability we choose a senior or a male out of all of these students? So there's 8 total here, 14 total here, or 22 total. Did I add that right? Okay, so senior or a male. So all the seniors count plus anybody who's a male. So that would be 4, 5, and 9 all add up, or 18 out of 22. Did anybody else get that? Add the seniors and the males, or add the males and any extra that are seniors. So 9 out of 11, right? Oh, that's a horrible box. Junior or a female. Everybody's a winner if they're a junior or a female. How many? 8 juniors plus 9 female seniors is 17 out of 22. Did anybody get that one way or the other? Junior or senior? Everybody's either a junior or senior, right? In our math class it says 100%, 1, something like that. 22 out of 22. I'm going to stop because I don't think these are on Delta Math. We'll pick up there tomorrow, okay? But I think that will be enough for you to get through the first Delta Math assignment. Tomorrow is a warm-up. Help me remember, okay?